Good morning, everyone. Today, we will be presenting our research on the effect of reactor temperature and feeding ratio on fed batch composting of household food waste and green waste. First, what is the food waste? Food waste is food discarded by most of the household that could have been eaten or used. Household food waste make up most of China municipal waste, and usually these waste treated in the large treatment center, which leads to the high cost and environmental issues such as high collection and transportation costs. Our study focused on a more sustainable and decentralized approach on fed batch composting, which allowed daily waste to be added in small amounts, making it suitable for on-site treatment. By combining the household food waste with green waste, improve compost quality by balancing the nutrients and moisture. So our main objective was to evaluate how different reactor temperatures and feeding ratios influence composting efficiency and the quality of the final product.
Hello everyone, I will now be presenting the methodology used in this study, which investigated how reactor temperature and feeding ratio affect the efficiency of fed batch composting of household food and green waste. The first step is material collection, where household food waste was collected daily from 10 households in Kunshan, China. Non-compostable items such as bone and napkins were removed. The collected waste was then crushed and stored under refrigeration to preserve its condition. Green waste used to adjust the moisture content and the carbon to nitrogen ratio of the composting mixture. The second step is reactor setup. A fed batch composting reactor was used for all treatment. It was equipped with internal stirring, heating capability, and aeration system. Each composting cycle began with 1.5 kilogram of green waste, depending on the experimental treatment, 0.25 to 1.0 kg of household food waste was added daily. Next is experimental design. This study was divided into two main experiments, which Experiment 1 assessed the effect of reactor temperature, and Experiment 2 is to examine the effect of varying feeding ratios under a constant temperature of 50 degrees Celsius. Next step is composting process, where each treatment was conducted over a period of 60 days. Oxygen was applied through the internal ventilation system to maintain aerobic conditions. For the compost monitoring and sampling, the moisture content, organic matter, and carbon to nitrogen ratio were measured every 3 days. Weight loss was recorded every 2 days, and at the end of the composting, samples was analyzed for nutrient content and seed germination index. Lastly, the laboratory analysis, where the moisture determined by oven drying at 105 degrees Celsius for 12 hours. The organic matter content measured by ignition at 550 degrees Celsius in a muffled furnace. The carbon to nitrogen ratio was calculated based on the total organic carbon and total nitrogen values. The nutrient was measured from compost samples, and the germination index evaluated using a seed bioassay with Chinese cabbage. Meanwhile, the weight loss was calculated by the mass difference.
Now I will be presenting the results and discussion section of our study on fed batch composting of household food waste and green waste. First, we look at the effect of reactor temperature. Among the four temperature treatments, 35, 40, 45, and 50 degrees Celsius, we found that the 50 degrees Celsius gave the best results. At this temperature, the compost has the lowest moisture content at only 4.1% and the highest wet loss rate of 87.3%, which means more effective decomposition. The organic matter (OM) content was reduced to 66.1% and the germination index (GI) reached 74.1%, showing the compost was nearing maturity. Next, we tested different feeding ratios of green waste to food waste, which were 6:1, 3:1, 2:1, and 3:2. The 2:1 feeding ratio was the most efficient. It resulted in the fastest decomposition with a wet loss rate of 89.3%. OM content reduced to 63:1% and a stable CN ratio of 12.6. This shows that a balanced mix of green and food waste improves compost quality. Additionally, we applied a first-order kinetic model to simulate the composting process. It showed that reactor temperature had a greater impact on the rate of organic matter degradation than the feeding ratio. The degradation rate constant was highest at 50 degrees Celsius and with a 2:1 feeding ratio. Overall, these findings suggest that operating a fed batch operator at 50 degrees Celsius with a 2:1 feeding ratio produces the most efficient and mature compost, making this method practical for household food waste management.
In summary, our study showed that fed batch composting is an effective way to manage household food waste, especially when combined with green waste. We found that the best results were achieved by increasing the rated temperature to promote degradation of organic matter in the fed batch composting compared with the feeding ratio.
Finally, we would like to express our sincere gratitude to Southeast University and the Kunshan Construction Engineering Testing Center in China for providing the facilities and support necessary for this study. Their contributions were essential to the success of this research. Once again, we'd like to thank everyone who supported this research. That concludes our presentation. Thank you for your time and attention.